Globular cluster is a big sphere of stars that have collected together. They're orbiting around a common center, but it's very spherical, very organized, looks like a huge basketball. It contains hundreds of thousands of stars. These clusters have formed early on in the formation of a galaxy. When the cluster starts forming, it's very diffuse, and over time, things get concentrated more and more toward the center. Stars are actually moving all around in it. They're sort of orbiting around the center. It's not a static cluster, even though a single picture makes everything look like it's in place. I think one of the more famous ones is Messier 13. Omega Centauri is a prototypical one in the southern hemisphere. Globular clusters are very old. There seem to be some of the first stars formed in the galaxy as the material that came together in the past. One of the pockets of condensed material that occurred around the center of the galaxy drew together into these collections of stars. So they're mostly very old stars, 10 or 12 billion years old. Although we do see a second generation of newer, younger stars in globular clusters. Still, relatively old, billions of years ago, but it's not like it had one burst of star formation and that was it. You did have a chance to form a second wave later on. Westerlund 1 is what's called an open cluster. It's a very loose collection of stars over a broad area. It's more sort of a cloud of stars. As more stars gather in an open cluster like that and more material comes together, it's going to naturally pull things in toward its center. Something like Westerlund 1 over many millions of years could evolve into something that looks more like a globular. And we do think that most globulars have one or more black holes at the center, which is a source of immense gravity to help hold these clusters together. Hubble saw in the globular cluster NGC 6397 the first clear evidence for multiple black holes at the center. We had previously assumed that most globulars would have a single black hole at the center. In this case, we found a number of separate black holes. They're moving around each other at high speeds around a common center. If you have a number of black holes in tight orbits around each other at the center, that works as well as a single black hole for holding together the overall cluster.